Good day once again. In the last video, I've introduced you to the design of the analytical engine invented by Charles W. Babbage during 1837 in England. In this video, I'm going to demonstrate an actual program written to run on the said engine. You can see this program from different sites in the internet. This is called computing the fourth factorial. What is the fourth factorial? The fourth factorial is a special mathematical function that is used to compute the product of the first four numbers. For example, to manually compute the fourth factorial, you simply multiply 4 times 2 times 3 times 2 times 1, which will give us 24. You can also compute the third factorial by multiplying 3 times 2 times 1, which will give us 6. The fourth factorial is 24. In the language, and this program is in the language of the Analytical engine by Charles W. Babbage. Please take note that the same type of program was written by Ada Augusta King also during those period, which illustrates a much more complicated process, which is computing the nth number of the Bernoulli series. No matter what the example is, it serves the same purpose, which is to demonstrate that the analytical engine is programmable. So in this case, first we are going to assign values to a variable. Uh, in our worksheet, we have divided it in three different parts. We have the program in the Jacquard's loom. We have the ingress, the mill, which has the ingress axis 1 and ingress axis 2, and the output egress axis. And to the right is the store, which is composed of the variable 0 to 999. In this case, variable 000 is used particularly to store the next multiplier because factorial is a repetition of multiplication. And variable C001 is the standard decrement which is used to compute the next multiplier. For example, when the current multiplier is 4, to compute the next one, we'll have to subtract 1 from the current value, which is 4. So 4 minus 1 is 3, which tells us that the next multiplier is 3, and so on and so forth. And variable 002 is used to store the partial product in each multiplication of the factorial. So to make a long story short, variable 04 is the next 000, which will have a value of 4, by n004 is the next multiplier. Again, when we say n000 space 4, we are assigning the variable 00 a value 4. So in the second line, we have n001 space 1. We are assigning the variable 1 with a value 1. So this will have a value of 1. In the next line, we have n002 space 1. Variable 2 is also assigned another value of 1. Now the next operation is an x, which stands for times multiplication. Usually, commands are started with an operation card. In this case, the first parameter is the first load. So we have a times followed by an L002. Being the first load, it will load into ingress axis 1. L002 means take the value from the variable 002, which is currently 1, and store it to ingress axis 1. And then it is followed by another load, L000. Being the second load, it will load into ingress axis 2. By L000, we mean load variable 00 to ingress axis 2. So obviously this will have a value of 4. So this multiplication is used to compute the first partial product. Okay. So 1 times 4 means 4. So ingress axis will have a value of 4. Okay. The next command is S002, which means store. This is a variable card. Store the value of the egress axis into the variable 002. So this will have a value of 4. Column 002 will have a value of 004, which computes the first partial product. The second process is to compute for the next multiplier. Remember that the current multiplier is 4. So to do that, we'll have to subtract 1. So the next operation is a minus. Minus L00. Remember that L00 is 4. L00 minus 4 minus 1. L001 is always 1. So the ingress axis will have a value of 3 because we have the ingress axis being 4 and the ingress axis 2 being 1. So 5 minus 5. And then we will store it as the next multiplier by saying S000. So the ingress axis will be transferred to the 00 variable, which makes this 3. Now, the next operation is another times, which is used to compute the next partial product. Times L002. L002 is currently 4. Okay. The next multiplier 00 is currently 3. So 4 times 3 is 12. This becomes 12. Okay, and we store it to 002. So the value 12 is stored to this column 002, which is our next partial product. And then we repeat the process, which computes for the next multiplier. We say minus L00. We know that L00 here is 3 minus L001, which is always 1. So 3 minus 1 equals 2. And then we store it to 00. Again, this is 00, this becomes 2, which means that our next multiplier is 2. We repeat the process by computing the next partial product. We times L002, L00 is 2 is 12, and L000 is 2, being our next multiplier. 12 times 2 is 24, which stores the value to the egress axis. And then we store this to S002, which is our partial product, which makes it 24. And then we compute again for the next multiplier by doing a minus on the current value, which is n in L000, which is 2, and L001, which is 1. 2 minus 1 is 1. Okay, and we store it to the variable 000. And then we compute the final product again. We do a multiplication of L002, which is 24, and L00, which is 1. 24 times 1 is 24. And we store it as our partial product, 24. We are done because we have reached the multiplier of 1. And the next is a P. P means print, which means that the value of the egress axis, which is 24, is printed into the next card. And B means bell, to awaken the sleeping operator, and H means hot. In the next video, I'm going to show you an example, a simpler example, to convert values from particularly involving temperatures and distances like Fahrenheit to Celsius and meters to feet. So see you then.